Now, the intensity of a sound wave can actually differ depending on the medium you're in. As we previously saw, sound will travel at different speeds depending on the medium it's going through. And there is actually a formula to determine the intensity of the sound wave through that medium if you're given a particular velocity and power. So what we can show is that I equals the power squared divided by 2 times the density times the velocity. Now you can obviously prove that dimensionally, it all checks out. And we can also see that the intensity is inversely proportional to the density. So see, the more dense the material is, the less intense the sound actually is. And that's why we can't often hear certain sounds, especially going through water. See, water having a higher density than air, it's very hard to hear under the water. And we'll go straight into an example. And here it is here. So we have a water resistant phone that has a speaker which can emit a power of 80 watts. If the phone is dropped in water, find the intensity of the sound under the water at a distance of 2 meters away. And we're also told that the density of water is 1,000 kilograms per cubic meter, and the velocity of the sound is 343 meters per second. So you can go ahead and try this problem, and then when you're ready, you can come back for the solution. So again, we'll write down our formula. So the intensity is the power squared divided by 2 times the density times the velocity. Now the intensity of it is actually constant. It has no dependence on the distance away, which I think is quite remarkable. So we were given the power as being 80. The density of water is 1,000 kilograms per cubic meter, and the velocity is 343 meters per second. So that should be in kilograms per cubic meter, and that's in meters per second. So the intensity in watts per meter squared is 80 squared divided by 2 times 1,000 times 343. So if we work that out, because I haven't worked it out yet, it'll be 80 squared divided by 2,000 times 343. We should get a relatively small intensity, and we do. It's 9.33. So 9.33 times 10 to the minus 3, and then in units of watts per square meter. Now, in sort of doing this dimensionally, we get a unit of watts squared on the top, which we can convert into force by distance. And the force we can obviously turn into MA. So the masses would cancel in these, and you'd sort of get a difference in velocities here. So it all checks out dimensionally. And that is the intensity of that particular sound wave that's emanating from that mobile phone.